So what I say is that the cloud is probably useful for ultimately will probably be useful for about 99 or 99.9% of use cases, but there absolutely are workloads that aren't appropriate for the cloud. So let's talk a little bit about what are the characteristics of those workloads that aren't useful, for which the cloud's not useful. So number one is if you really care about your workload running on a particular machine, right? So if it needs to run on a particular piece of hardware, a particular chip, a particular mainframe, for example, then cloud is not appropriate. So all clouds are virtualized and you don't have access directly to the machines. That's part of what it means to be in the cloud. The second kind of workload is if you care exactly where in the world, where physically your workload runs. So, for example, algorithmic trading or high frequency trading, they need to have microsecond latency to the exchange, to the financial exchange. And so they need to put their machines right next to the exchange or very close by. So they can't run anywhere, they can only run there. The other example about when you might care about exactly where the workload runs is if you are in a regulated environment and then there are regulations about maybe financial regulations that you have to physically control, that you have to control physical access to the servers. And that's another example where you absolutely care exactly where in space it runs. But honestly, for the vast majority of workloads, even at institutions that have regulated parts, like most of the operations at a bank are not these regulated instances, are not these regulated workloads, and those absolutely can and are starting to be run in the cloud. So one of the things I like to say is the 2010s of computing are a lot like the 1910s of electric power. So what I mean there is when Henry Ford in the United States was inventing the assembly line, the first thing he needed to do to build a factory was, he couldn't just start building a factory. He first had to find a physical location where there was power. And only, a river where he could put a water wheel so he could power the factory. Only after that could he build a factory. And today we're a lot like that in computers, where first we need to build our own data center or rent machines from a co-location facility or managed hosting or something like that before we can do it. But electrical power today isn't like that. We have an electrical grid in most countries, and for most workloads, the electrical grid is perfectly sufficient. So we don't first have to think about building a power generation before we can have a factory. And I think computing is going to be like that very soon, where the vast majority of workloads will be best done in the cloud, like the electrical grid, but there will be some specialized workloads, just as there are some companies that need to build their own power generation for specific use cases. When we evaluate a technology, we really need to think about the context of it, and the solutions that are good at eBay and Google scale are appropriate for that context and for that scale, and are probably not appropriate, frankly, for much smaller scale. So in my sort of consulting and advising practice, I have a bunch of small startups in the Silicon Valley that ask me for advice. And so a lot of times people will say, hey Randy, please tell me about how you solve these problems at eBay or at Google. And I say, I'll absolutely tell you, but then you have to promise not to do them, because they're not the solutions they don't solve the problems that a startup has or a smaller company has. So it's very common, well, let's say it this way, don't try to solve problems you don't have, solve the problems that you do have, and you probably know the problems that you have right now, and you probably have good guesses about the problems that you will have in 6 months, 9 months, 1 year. But I strongly recommend not guessing about the problems that you will have in 5 years and building infrastructure for that. You're much better off putting your limited human resources, your limited machine resources, your limited money on solving the problems that you have right now, and only later trying to solve the scalability problems. And frankly, once you do have big scale problems, what's wonderful is a bunch of those problems are solved, and now you should go watch my presentation and see how to do it. But I wouldn't go and do that ahead of time. If you get to re-architect, that's a success. right? So one of the things I like to say, and it's a bit controversial, but one of the things I like to say is, if you don't get to re-architect your system, it's either because you over-engineered the first time, or because nobody cares. I mean, like, that's okay, right? Because you never reached the scale where you needed to change, and that's fine. So I guess the general idea is, it's wonderful to learn about what. Just keep in the back of your mind, when I have a scaling problem, come back and pick up the book again, or pick up the presentation again, and see how the big people are solving those problems. But you're much better off solving the problems that you actually have.